And welcome to day 2 of the 2021 SWAN Conference. Today will be our 4th annual Digital Twin Workshop focused on enabling holistic utility management. My name is Travis Kennedy. I'm the publisher of Water Online, and I'm honored to be your MC for this exciting day that we have ahead of us. First and foremost, though, we'd like to thank our sponsors of the Digital Twin Workshop, Esri and Metasphere. Also, make sure you check out the contests, thanks to VT SCADA, that we'll be running throughout the entire day with a bunch of prizes, including a few $100 online shopping cards. All these can be found on the contest tab. Some of these contests include the photo video submission challenge, where you take a photo of your virtual workspace, which we all have this past year, and a writing contest, answering in one sentence now, what is the future of smart water? Finally, don't miss out on the scavenger hunt challenge found on the reception page or the events feed page. So without further ado, let's get things started. As we get going, let me remind everyone to please engage in the Q&A during the panel we are about to enjoy. There's a lot of knowledge and expertise at your fingertips. So let's take advantage of it and enjoy the panel. I'd like to start by introducing someone who really needs no introduction. Gigi Carmus-Edwards has been our leader and guiding light throughout the years here at the Digital Twin Workshop. So Gigi, the floor is yours.
Thank you so much, Travis, for that introduction. And hello, everyone from around the world. Welcome again to the 4th SWAN Digital Twin Workshop. And wow, I mean, we have come a long way, baby, if you think about it. Just basically two and a half years ago, we started this journey together, developing this Digital Twin work group. We had about 60 people register for the Miami workshop, the very first workshop. 75 people showed up, so we know that we piqued some interest. And now, let's go ahead and show the slides. So let's see, yeah. All right, so I think the next slide, please. I just want to show some numbers that are really incredible. So we went from 75 people showing up to now look at these numbers that are attending the SWAN conference. It's amazing, and we're growing. So if you go back one slide, I'd like to introduce the co-chairs of the Digital Twin Working Group. Colby Manwaring, he's the CEO of Innovyze, now Autodesk. And again, that's a very interesting digital twin play, I believe, with Autodesk acquiring Innovyze. Very exciting. And also co-chair Andrew Fargas. He is the technology and energy leader for Aguas de Tarragona. They're going to be helping me through this introduction, and then we'll be followed by Dan Isaac. He's the CTO of the Digital Twin Consortium. So let's get started. You will hear, first of all, from some of the Subworking Group co-leads. Later on today in the masterclass, I really highly recommend it. It's going to be so knowledge filled with what we have been doing over the last 2 years and what we're planning on doing moving forward, and hopefully with everyone's participation. So next slide, please. Next slide. Yeah, so I want to update, no, sorry, go back. I want to update everyone on the Digital Twin Global Collaboration Working Group. We talked last time about BIM for Water and how we're bringing together the group from BIM for Water, part of British Water, with the Digital Twin Working Group. This year, just in the last few months, we created a partnership with the Digital Twin Consortium. And again, Dan is going to talk a little bit about how this partnership is really going to help the water sector and all sectors looking at digital twin. And then as of recently, the AWWA is now starting to work on a digital twin committee. We're working hand in hand, very aligned. The main reason for these alignments and these collaboration is so that from a water sector perspective, we're not duplicating efforts, we're actually complementing each other and accelerating and going even faster towards digital twin deployment in the water sector. So these collaborations are very important and very exciting. Next slide, please. And I also would like to introduce a labor of love that I've been working on. It's a large collaboration between the SWAN organization, myself, and Julius Education. We put together a introductory course to digital twin called Demystifying Digital Twins. And really, we focus on the fundamentals, the concepts, truly understanding why digital twin sits in a class by itself and the power and benefits of digital twin in the water sector. I hope you all can enjoy it and give us some feedback so we can always improve. Next slide, please. I want to just briefly talk about this concept of digital water versus digital twin. I've heard some in the past say that digital water is equivalent to digital twin. I feel like I don't think that that's the case. I think digital water is far greater. And if you show the next slide, I will, I see digital water as a huge umbrella. This is what SWAN has been about for all these last 11 years. The 5 layers of SWAN, the physical layer, the sensing, the data communications, the data management, and then of course the data fusion and analysis. All that is digital water, and it's huge. And we've all been living it and deploying it. Digital twin, I believe, is very, very specific area of digital water, and it involves at the core of it is the behavioral models of the systems we're trying to build a digital twin of, as well as the context data surrounding that digital twin. And overall, all of these, digital water and digital twin, provide us with insights that really results in the actions of the people. And then after a while, when we get very comfortable and start to trust those insights and those actions, we can move towards automation as well. So I just wanted to kind of, talk about the difference between digital twin and digital water. Digital twin is a subset. And then the last slide, I would really like to just hone in on the key differences between digital twin, and this is sort of a preview of some of the things that we talk about in the demystifying of digital twin. We have data analytics on one side and then digital twin simulation on another side. So data analytics is all about pattern recognition. It's using the science of statistics and analysis on big data, running those statistical analysis in order to get those insights or predictions, if you will. And again, data science can apply to all data sets. So it doesn't matter if it's water data or sports stats or traffic data. The same algorithms are being applied, the same statistical analysis or the science of data is being used to recognize pattern. Digital twin simulation is far, far different because at the core of it, we talked about this behavioral model that really takes in context the engineering of that system, deductive reasoning, scientific knowledge, expert experience, all that goes into the digital model or the behavioral model of the system we're trying to develop a twin. Then when you marry that with big or small data, you get an enormous amount of benefit and exponential return on investment because of the synergy that occurs when you have a calibrated model of the behavior with the context data. So I believe, what I'm trying to show here is that digital twin is different. It is a subset of digital water, but it's very specific and it's very powerful. And with that, I would like to introduce Andrew, and he can go into more details about the work. Here you go.
Thank you, Gigi. And following that Gigi introduction, the next thing is what is the definition for digital twin for water utilities? And it may look simple, but it has been a really hot topic through all the meetings that we have in the working group. And in fact, this definition has been evolving during the years. If you think of the first workshop 2 years ago, it really have evolved. And I'm pretty sure that it's going to be evolving in the next workshop because it happens, this evolution, it's related to the fact that we are still defining what things we can really do with a digital twin. But at the present time, between all the co-leaders of the different subgroups, we have been able to reach a consensus that this definition at this present time, everybody really agrees on it. And we have said that a digital twin is a dynamic representation of a real-world system that is used to describe, diagnose, predict, and optimize through actions enabled by a combination of models and static and dynamic data. And here you can see the 4 main components that we understand that a digital twin must have. First of all, we need a dynamic representation of a system, of something, the something that we are twinning, okay? Then we need a model that gives us that tries to twin the behavior of the system. We need inputs in the form of those static and dynamic data. And then what's more important, we have a goal, an output, some informed decision, some actionable results that we want to get. Because really, that's the most important part. We don't want a digital twin just for the sake of a digital twin or because it's trendy. We want to do something. We want to improve our system. We want to get some output. Maybe at the beginning, it's just to describe what's happening in our system. But when we reach that step, probably we will want to diagnose if our system is working properly or not. And after that, maybe predict what's going to happen tomorrow. And finally, what we can do to optimize our system. What inputs do we have to produce so that our system really behaves as we really want the system to behave? And that's what really makes digital twins so powerful. That's what it makes so usable for digital for water industries. Okay, because that allows us to get a really good insight on our system and really make it work as we really want. But at the same time, I would emphasize that having a clear idea of what's the output that we want, it's really important from the beginning, and it will really affect what's the success of our digital twin implementation. Because really, there's multiple ways of building a digital twin, okay? But depending on the output that we want, that will really affect what models are we using inside the digital twin, and which kind of data we are going to collect to really make work this digital twin to give those actionable results that we really need. And based on that, now Colby will go and give you more details on these 4 components of the digital twin.
Thanks, Andrew. Yeah, I wanted to dig in just a little bit to the basic building blocks of a digital twin. Please go ahead. It looks like 2 slides ahead. As Andrew was pointing out, one of the first things that a digital twin requires is actually a goal or an objective, a desired outcome. That desired outcome then can inform the types of data or the pieces, components of the digital twin that you need to accomplish the goal. Now, I know that the 4 concepts here on this slide are perhaps remedial, but as Gigi said, we went from 60 to 75 people to now 600 plus. I'm sure there are new entrants to the digital twin concept, so I thought it might be worthwhile to drill in briefly to the absolute basic building blocks. So the first building block, of course, is data about the physical system that you are trying to replicate, that you're trying to investigate. Again, depending on the outcome you want, this might require different data. If your digital twin is to predict flooding, of course, you might need data about the physical aspects of the river channel. You would want data about the roughnesses. You would want information about flood walls, flood protection, location of buildings. On the other hand, if your digital twin objective is to reduce operating costs in a water treatment plant, of course, that's a very different set of data about the physical assets of that plant. But I think that's where most everyone has started, whether last week or 10 years ago, is gathering asset data, physical asset data, into a software system of some sort that can be the basic building block of a digital twin. Once the physical asset data is in there, the geometries, the material types, the sizes, typically the next step is the contextual data about those assets. So this could be like a live data stream from a data sensor. A water quality sensor in a treatment plant, for example, gives us contextual data about what is happening with those physical assets. This contextual data also might be historical data. So how often has a particular section of a river been in flood condition? It might be operational data, such as for a pump, what's the current energy consumption, and what is the operational control status of the of a variable speed pump, or just even a single speed. Is it on or is it off? So operational data, historical data, and contextual data about the assets is typically the next building block that people would approach and put into, again, to a software system that can describe the physical system, the real world, and do that in a digital way. The third component of a digital twin is a behavioral model. Well, I shouldn't say a behavioral model. It's often various behavioral models. So again, this depends, the model you use depends on the outcome you want. There are physics-based models, of course. There are data-driven machine learning models. There are statistical models. There are just, simple experience or rules-based models. The point of all of this is to have a software model, have an algorithm that takes the physical data, the contextual data, and can tell the user of the digital twin what has happened, what is happening right now, and what will happen next. That's the key part of the behavioral model aspect of a digital twin. And of course, if we look at the definition of a digital twin, which Andrew presented a moment ago, as well as, again, there are different definitions around different industries. All of those include the goal of creating a digital system that replicates the life of the real world system. Thus, the behavioral model is absolutely key, and that's the piece that we are relying on to replicate the real world in terms of behavior. And that leads us then into the fourth component of a digital twin, which is really user interface. And of course, this is not a sequential approach. Of course, you need a user interface when you start collecting physical data. You often need an interface, of course, at the end when you're looking at outputs. But a user interface, the key point here is that a digital twin has to be accessible to those people that are.
2-minute warning.
I'm sorry, is someone off mute?
2-minute warning.
2 minutes, yep. So the fourth component being the user interface. Look, this comes in the form of 3D visualization. Sometimes it comes in the forms of charts and tables. It comes in the form of specific prescriptive recommendations, such as how to change your pumping speeds to conserve energy. That's an output that comes through user interface. It might go to an operator, or perhaps it goes straight to an automation control system. But you've got to have an interface that allows the people involved in digital twin to use and understand the digital twin. So again, these are generic basic building blocks. We dig into each one of these, and we have been digging in for several years. Go to the next slide, please. I wanted to note the the sub-working groups that we've put together several years ago. The purpose of those is to dig into the basic building blocks and to produce particular outcomes. So we have 4 sub-working groups. The architecture group, which as the name implies, is about the building blocks and the interfaces that I was just talking about. We've got the outcomes and ROI subgroup, focusing on why do people use digital twins? What's the return on investment of the time and effort and money you use to build a digital twin? We've got a digital twin lifecycle subgroup that is looking at these things evolve and change over time. What's the pathway? What's the best practices for managing the life cycle of your digital twin? And then the BIM and asset management group, which is looking into more of the data side, right? What is the physical data and the contextual data that is necessary to drive a digital twin? These sub-working groups you'll hear from today in our masterclass, but the whole point is to raise awareness of digital twin concepts, identify key challenges, collect best practices, and ultimately to help us all increase our adoption rate of digital twins.